Maths. In this video, let me discuss an example in a Fourier series. Here, let me take f of x as an exponential function, that is e power ax, and let me see how to expand this function as a Fourier series in the interval 0, 2 pi. Before we enter into the problem, let me have a short look over the important formulas that we are going to use in the problem for calculation of the Fourier coefficients. So cos n pi is equal to minus 1 whole power n, whereas cos 2n pi is plus 1. Likewise, sin n pi and sin 2n pi, both of them become 0. And also, you may know one more formula, that is a very simple formula. Cosine 0 is 1, whereas sin 0 is 0. So here we are going to discuss about the exponential function, that is integral e power ax cos bx dx is equal to e power ax divided by a square plus b square of a cos bx plus b sin bx, and the next one is integral e power ax sin bx dx is equal to e power ax divided by a square plus b square of product a sin bx minus b cos bx. And one more thing I have to recall it here, while you integrating e power x with respect to x, you get e power x. And if you integrate e power ax with respect to x, you get e power ax divided by a. That is, the coefficient of x occupies the denominator. Whatever may be the value of a, here I have to take a as a constant. So if it is 2, 3, whatever that may be, so you are writing in the denominator. So these are all the simple formulas that we are going to use in the problem of f of x is equal to e power ax. So before that, let me give a short intro about the general form of the Fourier series in pi form. That is, here we have to discuss about 0 to 2 pi. That is, the functions defined in the interval 0, 2 pi. If so, the general form of the Fourier series is f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n x plus sigma n is equal to 1 to infinity b n sin n x. Here a naught, a n and b n are Fourier coefficients that are calculated by make use of these formulas. That is, a naught is calculated by make use of the formula 1 by pi integral 0 to 2 pi f of x dx, whereas a n is calculated by make use of the formula 1 by pi integral 0 to 2 pi f of x cos n x dx, and b n is calculated by make use of the formula 1 by pi integral 0 to 2 pi f of x sin n x dx. Okay, with this short introduction, let me now enter into the problem. Expand the function f of x is equal to e power ax as a Fourier series in 0 to 2 pi. So first let me write what is the given function. Here the given function is f of x is equal to e power ax. That is an exponential function defined in the interval 0, 2 pi. So first let me write down the general form of the Fourier series. That is, write f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n x plus sigma n is equal to 1 to infinity b n sin n x. You take this as equation number 1. Next, where a naught is calculated by make use of the formula 1 by pi integral 0 to 2 pi f of x dx, take this as equation number 2. And a n is calculated by make use of the formula 1 by pi integral 0 to 2 pi f of x cos n x dx. You take this as equation number 3. And b n is equal to 1 by pi integral 0 to 2 pi f of x sin n x dx. You take this as equation number 4. So by making use of these formula, we calculate the Fourier coefficients a naught, a n and b n, and substitute in equation 1, the problem will be over. Okay. First let me calculate the value of a naught. So from equation 2, here a naught is equal to 1 by pi integral 0 to 2 pi f of x dx. Here our given function f of x is e power ax. Just replace f of x by e power ax, that is 1 by pi integral 0 to 2 pi e power ax dx. While integrating e power ax, as I told you earlier, so integrating e power ax, you get e power ax divided by a with the limit from 0 to 2 pi. Now let me substitute upper limit minus lower limit. First we substitute upper limit, that is 2 pi. Just replace x by 2 pi. So e power 2a pi. I am just write 2 in front. Okay. 2a pi divided by a minus. Coming to the lower limit. So in lower limit you have 0. So you have to replace x by 0. So you get e power 0 into a, that is a. That is product of a with 0 gives you only 0 itself divided by a. So only one parenthesis enough. So that is equal to 1 by pi e power 2a pi divided by a minus e power 0 is 1 divided by a. So here a is a common term in the denominator. So you take it outside of the parenthesis, you get 1 divided by a pi of e power 2a pi minus 1. So this is your a naught. Next, we calculate the value of a n. So from equation 3, your a n is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. Now you have to replace this f of x by the given function e power ax, that is 1 by pi integral 0 to 2 pi e power ax cos nx dx. So e power ax cos nx dx. You know, as I told you already, you know the formula. If the integration consists of the products of the function like this, so we have a formula to evaluate this integral. I just write it here. Integral e power ax cos bx dx is equal to e power ax divided by a square plus b square of a cos bx plus b sin bx. So here you have in the formula, in the exponential power you have a, here itself we have a. Whereas in the cosine term having bx, here instead of b, here we have n. So you just replace only b by n. Just replace only b by n. So we have the evaluation of the integral, that is 1 by pi e power ax divided by a square plus instead of b square write n square, because instead of cos bx here we have cos nx. So this is the only difference. So replace b by n in this formula. So of a cos bx is nothing but nx plus b sin bx. You just replace here itself you have b. So n sin nx. So with the limit from 0 to 2 pi. Now let me substitute the limit. For that, upper limit minus lower limit as usual. First, these are all the, let me mark the portions of x. Okay, these are all the portions we are having x. So you just replace x by 2 pi first. So e power, if you replace this by 2 pi, you have a 2 pi, that is 2a pi. I write 2 in the front divided by a square plus n square of, listen here, if you replace this x by 2 pi, you get cos 2n pi. The value of cos 2n pi is, as I told you already, cos 2n pi is plus 1. So if it is plus 1, so you have a product 1 plus n sin nx. If you replace this x by 2 pi, so you know the value of sin 2n pi, the sin 2n pi is 0. So this entire term becomes 0. So upper limit over minus. Coming to the lower limit, if replace this x by 0, so you have e power 0 divided by a square plus n square of cosine 0. If you replace this x by 0, what you get? cos 0. Cos 0 value is 1. So if this term becomes 1 means a product 1, that is a product 1 plus sin 0 value. Sin 0 value is 0. So if we replace this x by 0, you get sin 0. Sin 0 becomes 0. So the entire term becomes 0. So there is no term here. So this becomes 0. So let me simplify here. That is 1 by pi of e power 2a pi divided by a square plus n square of a. Here you have minus. So minus e power 0 is nothing but the value of e power 0 is 1. So 1 divided by a square plus n square of a. That's all. Look into the parenthesis. So here a divided by a square plus n square is a common term. So take it outside. So a divided by, already you are having pi in the denominator outside here. So pi of a square plus n square. So you take a by a square plus n square outside of the parenthesis. If so, you get of e power 2a pi minus 1. So this is the value of, you can't simplify further, okay. So this is the value of an. Okay. Now let me move on to calculation of bn. So from equation 4, here bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. So let me first replace the function f of x by e power ax, that is 1 by pi integral 0 to 2 pi. If you replace f of x by e power ax, so e power ax sin nx dx. So whenever you are having the exponential term along with sine function, so we have a formula, I write it here. So integral e power ax sin bx dx is equal to e power ax divided by a square plus b square of a sin bx minus b cos bx. So this is a formula we have used, okay. So now this is equal to 1 by pi of, look at here, instead of, so here itself we have exponential power a, in the formula itself we have exponential power a, but here whereas sine function have bx, here sine function has nx. Only the difference is you just replace, in the formula you just replace b by n, that's enough. Replace b by n. So if you replace b by n, we have e power ax divided by a square plus b square, sorry, instead of b we have n. So a square plus n square of a sin nx minus n cos nx, that's all. The limit from 0 to 2 pi. Now let me substitute the limits. For that we have to replace the value of x by 2 pi first and then minus lower limit 0, okay. So first let me substitute the upper limit. So 1 by pi of e power, if you replace this x by 2 pi, you have e power 2a pi divided by a square plus n square. So as I told you already, sin 2n pi. If you replace this x by 2 pi, you get sin 2n pi. The value of sin 2n pi is 0. Since the value of sin 2n pi 0 means a product 0, 0 itself. So minus n cos, if you replace this x by 2 pi, you have cos 2n pi. As you know already, cos 2n pi value is plus 1. So 1, okay, n product 1. Upper limit over. Minus, coming to the lower limit. So if replace the value of x by 0, e power a product 0, that is e power 0 divided by a square plus n square of, here itself you know the formula, that is the value of sin 0, because sin 0 value is 0. So if you replace this x by 0, sin 0 becomes 0. So here we have 0, first term becomes 0, minus n product cos, if you replace this x by 0, cosine 0 value is 1, cos 0 is 1. So you have n product 1, that's all. So that is equal to 1 by pi. Simplifying this, you get e power 2a pi divided by a square plus n square of minus n. Here, look at here, you have both, here itself you have minus and minus becomes plus. And also e power 0 value is, e power 0 is 1. So 1 divided by a square plus n square of n plus n. That's all. Look at the values inside the parentheses. If there is any common term, you take it outside of the parentheses. Okay. So here, shall I take minus n by, I'm going to take minus n by a square plus n square as a common factor and take it outside. So minus n divided by, so already we are having pi also outside of the parentheses. So pi of a square plus n square product. So e power 2a pi. So if you take minus n outside, so here you have minus. That's all. So this is the value of Bn. So you can't simplify this further. So leave it as it is. Okay. So this is the value of Bn. So after calculating all these values of A0, An and Bn, so let me substitute all these values in equation 1. So substituting the values of A0, An and Bn in equation 1. So you get this here for equation 1. So your A0 value we have calculated as 1 by a pi of e power 2a pi minus 1. This is our A0 value. Divided by 2 plus sigma n varies from 1 to infinity. Your An value is a divided by pi of a square plus n square of e power 2a pi minus 1 of cos nx. This is your An. Okay, this is your An of cos nx plus Bn is sigma n varies from 1 to infinity. Your Bn value is minus n divided by pi of a square. This is your Bn value. So if there is an n term within the summation, you take it outside or just leave it as it is. That is not a problem. Okay. So this is your f of x. So or otherwise you have to simplify like this. You take this. So if you take this 2 or a by 2 the denominator, you get 1 divided by 2a pi of e power 2a pi minus 1 plus. So this summation is only for n terms. So look at, take the other terms, constant term outside. So e power 2a pi minus 1 divided by pi, these are all constant terms. So take it outside of the summation. So a of e power 2a pi minus 1 divided by pi sigma n varies from 1 to infinity. Here you have 1 by a square plus n square alone within the parenthesis of cos nx plus, look at the sin nx, that is the second summation value. So here e power 2a pi and pi divided by pi. This is a constant term. So take it outside. So along with minus 2 you have to take it outside. So if you take outside, so minus e power 2a pi minus 1 divided by pi of sigma n varies from 1 to infinity. So here within the parenthesis you have minus n divided by a square plus n square of sin nx. So you can't simplify further. Okay, that's all. So this is the Fourier expansion of the given function f of x is equal to e power ax, that is given in the interval 0, 2 pi. Suppose you may expect a problem like this too. That is, expand the given function f of x equal to e power x as a Fourier series in 0 to 2 pi. So only difference is the problem we have discussed having the exponential power e power ax, but here you have e power x. So in the previous problem we just replace a by 1 means that is the value of a naught, an and bn. If this problem is a continuation of this problem is a continuation of the previous problem, means you can't execute the problem from the beginning itself. The final term, that is in last term you are having your f of x, here you have to replace just a by 1. So you get the Fourier expansion of this function f of x equal to e power x. Or otherwise, if it is a separate question means, so you have to proceed as usual. First write down the given function f of x equal to e power x and write down the general form of Fourier series and make use of the formula e power x cos bx dx for calculating a naught and e power x integral e power x cos sin bx dx for calculating bn value. So the same procedure that we have followed in the previous problem, here itself we make use of that. So here, look at here you have the value of a is 1. Okay, that is the only difference. Okay, so do by yourself. So this is for your self practice. Hope you got a clear idea about how to expand a function. That is, if an exponential function is given, how to expand that exponential function as a Fourier series in the interval 0, 2 pi. Thanks for watching. See you all again in my next